The next property we are going to see is converse of basic proportionality theorem. What does this theorem state? If a line divides any two lines of a triangle in the same ratio, then the line is parallel to the third side. So let us see, if I am drawing a triangle ABC. This is my triangle ABC. It tells that suppose a line divides AB and AC of a triangle ABC in point P and Q. So if I try to draw a line L which divides my side AB at point P and side AC at point Q. Okay. Now the ratio in which AB is divided should be equal to the same ratio in which AC is divided. That means if AP upon PB is equal to AQ upon QC, if this is the condition, then we can say line L is parallel to BC. Okay, so that means suppose if a line divides ABC, triangle ABC, and that to the two sides of the triangle ABC, that is AB and AC, in the same ratio, that is if AP upon PB, that means the ratio of AP upon PB is equal to ratio of AQ upon QC. In that case, we can tell that line L is parallel to line BC. Okay, so this is termed as converse of basic proportionality theorem. Okay, now we shall go to the next property, which is based on property based on BPT, that is property of angle bisector of a triangle. The theorem states that the bisector of an angle of a triangle divides the sides opposite to the angle in the ratio of the remaining sides. So what does this particular statement mean? We have a triangle ABC where bisector of angle C intersects seg AB in point E. So let's draw the figure. This is my triangle. This is C. This part is A and B. We have a bisector. We have a bisector of angle C. So this is a bisector of angle C in triangle ABC. It intersects AB at point they have given D. It intersects at point, it is EE. It intersects at point E. So in triangle ABC, the bisector of angle C intersects seg AB at point E. We are supposed to prove AE upon EB is equal to CA upon CB. So it is AE upon EB is equal to CA upon CB. That means it is equal to CA upon CB. This is what we are supposed to prove. We are supposed to draw a construction, draw line parallel to CE. We are supposed to draw a line parallel to CE. So if I supposed to draw a line parallel to this thing CE, can we draw a line here intersecting this thing C passing through point B extend AC such that it intersects at point D. So what he has given, we are supposed to draw a line CE passing through point B. That means the line should be like this. Is it correct? It should be parallel to C, and AC, it should go and intersect AC at point D. Okay? So this is my construction. We have drawn BD parallel to CE. It is intersecting AC at point D. Okay? So how are we supposed to prove this particular part? The first statement we'll try to take is number 1. Measure angle ACE is equal to measure angle BCE. Reason for this, ray AE is angle bisector. Second, so we got these two angles are equal. Angle ACE is equal to angle BCE. Second point, angle ACE will be congruent to angle CDB. Measure angle ACE will be equal to measure angle CDB. CDB. Reason for this will be corresponding angles test. See children, the lines are parallel. So will I get this angle here will be congruent to this angle. So I wrote angle ACE is equal to measure angle CDE. Same is the case, I'll get this particular angle congruent to this. So it is the third statement, angle BCE, measure angle BCE is equal to measure angle BCE equals to measure angle CBD. CBD. But this time the reason will be alternate angles test. Okay. Now let us try to club 1, 2 and 3. What do I get? If you observe it properly, statement number 2 and 3, it is ACE is equal to CDE and BCE is equal to CBD. You check it out, statement number 1 tells the LHS of 2 and 3 are equal. Correct? Since these two angles are equal, means angle ACE is equal to angle BCE, whereas partner of ACE is equal to CDB and partner of BCE is equal to measure angle CBD. So what do I get is that these two angles, means I'll just put up in short, one is equal to 2. 1 is equal to 2 angle bisectors given, but 1 is congruent to 3 corresponding angle and 2 is congruent to 4 alternate angles. With this I can get 3 is congruent to 4. So let's enter the triangle and put it up. Point number 4, in triangle CBD, in triangle CBD, angle CDB will be equal to measure angle CDB will be equal to measure angle CBD. This I get from 1 comma 2 comma 3. But children, if suppose the base angles are congruent, if the base angles of a triangle are congruent, will I get the opposite sides will be congruent? We have a triangle CBD where we tell that point angle 3 is congruent to 4. If the base angles are congruent, will I get the sides opposite to them are congruent? So this gives me seg CB is equal to, congruent to seg CD. Reason for this is isosceles triangle theorem. Now, point number 4. Point number 5. Now, based on this particular property, I'll just try to explain here. We got something CB is equal to CD. Now, let's see some big triangle here. This was C, A, B, and this point was D. According to construction, we have drawn CE is parallel to DB. Correct. In our construction, it was given that we are supposed to extend and draw a parallel line CE passing through point B, extending AC so that it intersects at D. So we have been already written that in construction, CE is parallel to DB. So we have a triangle, and in this particular triangle, CE is parallel to DB. So with this particular aspect, we can apply BPT here. If I apply BPT here, what do I get? I'll get CA upon CD is equal to AE upon EB. So in triangle ADB, CE is parallel to BD. This is by construction. Therefore, if I apply BPT, I get CA upon CD is equal to AE upon EB. This comes by basic proportionality theorem, what we call it as BPT. Now, in statement number 4, you have already proved CD is equal to BC. So I have got here CD, and in place of CD, can we substitute, instead of writing CD, can we write it as BC? So if I try to put in this CD's place, substitute and write CB, what do I get? So the next step will be point number 6, which states that CA upon, instead of writing CD, I can replace it by CB. This is equal to AE upon EB. This I am getting from 5. I've substituted the value of 4. Am I right? So this what I have proved, it is what CA upon CB is equal to AE upon EB. This is what was my to prove that. If you see AE upon BE is equal to CA upon CB. Is it the same thing? It is AE upon CB is equal to AE upon EB. This is what we had to prove, and this property is known as property of angle bisector. Property of angle bisector of a triangle.